This is our example number one question here. Here we have a balanced scale. We don't know what those boxes equal. If we change both sides by the same, is it still balanced? In other words, if I add something on one side and add it on the other side, is it still balanced? If I subtract something from one side, subtract from the other side, is it still balanced? So we're going to be looking at all the operations. We're adding, subtracting, multiplying, and dividing. So in order to do this, you can look at these as variables, but I'm going to go ahead and explore with this as 10. This in the middle is always my equal sign. I've got 10 over here. So I'd like you to write or divide your notes into 4 different sections and then write these comments above. Add 10, subtract. Sorry, I want this to be subtract 2. Multiply by 3 and divide by 5. So that's what we're looking at, right? So within each of these columns, I would like you to write 10 equals 10. So remember, we're not looking for answers mostly with this unit. It's more, do you know how to set up the process? Do you know how to show your algebra steps? So I wrote 10 equals 10 equals 10 equals 10 across all 4 of these sections. So we're just simulating our balance beam here, and then we're going to add 10 to both sides. So what this looks like algebraically is I'm saying I'm adding 10 over here and I'm adding 10 over here. And then we'll draw a line to say we're going to get a new equation. So 10 plus 10, we kind of just you kind of just solve the problem on one side of the equal sign and solve the problem on the other side of the equal sign. The equal sign will just come back down. So just bring that equal sign down in between. And we got 10 plus 10 is 20. And on the other side, we got 10 plus 10 is 20. So now we're doing the same thing, but we're subtracting 2 from both sides. So we're minusing 2 over here, and we're minusing 2 over there. So again, draw your squiggly line, and it's going to change this. Our equal sign comes down. 10 minus 2 is 8, and 10 minus 2 is 8. Now, I know this requires some writing, and some of us can get stubborn in that process, but these problems are very easy right now. They're going to become a lot more challenging. And again, it's not, I know you guys can do these math facts. It's, have you seen this process of how to solve equations before? That's really what we're working on. So now we're multiplying by 3. So I'm going to do times 3 here and times 3 on this side. Draw my squiggly. 10 times 3 is 30. My equal sign comes down. 10 times 3 is 30. So what we're noticing, it doesn't matter what we do, as long as we're fair and do one thing to one side and fair and do the same thing to the other side, we're going to keep this equation equal, even when you divide. So with divide, we're just going to put a fraction bar, which also is division. So we're dividing by 5 on both sides. We're going to do a squiggly. Okay, 10 divided by 5 is 2, and 10 divided by 5 is 2. So what you've learned through this process is it doesn't matter what operation, addition, subtraction, multiply, or divide, but as long as you do them the same side, it's always equal. Something to keep in mind, can I add 10 to one side and subtract 10 to one side and expect that to be equal? No. They have the same number, 10 and 10, but one was added, one was subtracted. That's not the same. So you always have to do the same thing to one side of the equal sign that you're going to do to the other side of the equal sign.